Hi, this is Frazier Nyasulu again. This week's lab, or the lab that you'll be doing in the next 1 or 2 weeks, is identification of ionic compounds. So, imagine you are given an ionic compound. It's not molecular, you're told it's ionic, and then you're supposed to come up with the identity of the compound. Is it potassium chloride? Is it ferric nitrate, or whatever it is? That's our exercise today. All right, so let's pick up a pen here, point the options. All right. So, we'll have to do something in order to identify the ionic compound. And remember, the ionic compound consists of a cation and an anion. So our identification must actually identify both. In a given substance, identify both, and then you can come up with the formula, the correct formula, and the name. So that's what we're doing in this lab. Just a reminder about ionic compounds are all kinds, but some of which we're going to deal today are ones that involve a metal and a non-metal. Remember, metals lose electrons, non-metals gain electrons, and in that way form an ionic compound. Simple examples here: sodium plus, that's in group 1. The chlorine is in group 7, so it's -1, +1, and so it's NaCl for the formula. If you take magnesium, magnesium is in group 2, so it's 2+. OH minus, that's a polyatomic ion with a charge of minus. In order for the formula to fit, it must have 2 hydroxides. Moving right along. So, here's what we have. Our possible cations. We can't just start with the whole group because we can't do it in the lab time that we have. So we are telling you that in this case our possible cations are those: sodium, potassium, and iron 3+. The ferric ion, +1, +1, +3. For the anions, these are the possible anions: chloride, bicarbonate, carbonate, sulfate, and phosphate. And so you can combine one from the cation and one from the anion and come up with several possibilities for the ionic compounds. How are we going to identify them? Well, there are 2 kinds of tests that we're going to do. Physical tests, meaning that we really don't change the identity of the ion, it remains as is. And in a chemical test, the ion kind of participates in a reaction, so it's changed in the process, and by observing what products are formed, we can infer the identity of the anion. So, here are our tests. So, we're looking for chloride. There must be something we can do to identify chloride. Chloride from amongst all the others. And then carbonate, bicarbonates is a test that actually doesn't distinguish between those 2. Phosphate, there's a test for that. Sulfate, there's a test for that. For the ferric, yes, there's a test for that. The sodium and the potassium. These are the metal ions, and these are the anions, some of them as a single atomic species and the rest of them as polyatomic. Of course, I know that one of the things that you guys are required to know is get to know your polyatomic ions. So here's how. We will have a control solution. For the control solution, we will know what is in there. So, for example, we might decide, in this case, that we have chloride in test tube number 1. And then we're testing for chloride. in 4 unknowns. Okay? So we go 2, 3, 4, 5. Whatever test we're performing, we're able to see, since we know this is chloride in this case, in this example, we'll be able to see exactly what the test reveals. Is a change of color, whatever is going on, we'll be able to see. So we'll know what the result for the chloride test is, and then we'll look at that and compare within 1, 2, 3, 4 which one of these matches the control. And we do that for all of these, and so it makes it kind of, we have the control and we match them in order to see which one's a good fit. All right, so chloride. How do you identify chloride? Well, it turns out that for chloride in this case, you can identify it by adding silver nitrate. So first you must take chloride, which will come to you as a solid, dissolve it a little of it in solution, so you have NaCl aqueous, will give you AgNO3 aqueous silver nitrate. And when these react, they form a precipitate. Not the language. Precipitate. And the precipitate or solid phase is silver chloride. And so when we do this test, we'll be able to see silver chloride. It's a solid, so it will come at the bottom, of be able to see that the solid has formed. Color, it's white, and so when we see that amongst unknowns 2, 3, 4, and 5, we will know that that solution contains chloride. For the carbonate bicarbonate test, what we'll be doing is just adding acid. Adding an acid provides the hydronium ion, or in this case we'll call it just H+, and the reactions occur to produce carbon dioxide gas. So if we have the unknown containing carbonate, we'll see how it behaves, how it gasifies, and then we'll look at 2, 3, 4, 5 and see which one of those gives the same characteristics. If we do find that one of them gives the same, then we must conclude that that test tube or that unknown contains carbonate or bicarbonate. Phosphate, this one requires heating. And so it might be useful to start this reaction early for these, so you can actually have it going while you do other tests. And we're looking for, in this case, a yellow precipitate. What's happening? Ammonium molybdate. Ammonium molybdate. Molybdate. And here I've decided I won't give you the formula for that. It's some complex thing. And nitric acid, we know that that's HNO3. And the phosphate, if there's a phosphate, then you get a yellow precipitate. Phosphate. PO4 3-. For the sulfate ion, it's a precipitation reaction. That is, if a test tube contains or non-contains sulfate, then if we add barium 2+, we form barium sulfate. And so again, this is a white precipitate. White precipitate here, white precipitate here, but knowing what we're doing at each individual step will allow us to find out what is going on. All right, so those are the anion or negatively charged ion tests. For the cation test, for the ferric, that is the Ferric Ion Test, we'll add a solution containing thiocyanate, SCN-. For this reaction, it's kind of nice and kind of pretty, if you want to think of it that. I do at least. You add, if there's iron, then it becomes a blood red solution. Blood red. Why don't they say just red? Blood red. So in the testing solution, you'll see what blood red looks like, and then unknowns 1, 2, 3, 4, 5. Which one of those goes blood red? Ha! Yeah. Life is good. For the sodium test, I had actually planned flame photometers, but they're not yet ready. And so what we do is you'll take a nichrome wire, nichrome wire. You kind of rinse it a little in HCl to remove any surface impurities or impurities from a previous test. Then you dip it in the solution and then put it in the flame. The flame will, in a transitory way, show a yellow color. If it does, and you'll see it in the control line, then it contains sodium. Same test with potassium, kind of violet flame. Violet flame, that's potassium. And so those are the tests that we're going to do. Now, to make things workable, so we're not all standing in line and doing the same thing, if you see a line, or your TA will assign you to different parts. But the point is, there's no use waiting in line when you can be doing something else. So watch out for that. We'll be working with HCl and HNO3, hydrochloric acid, and nitric acid. Those are strong acids, and in this case, they're reasonably concentrated. So watch out for that. Use gloves if you feel that you need to, and certainly put on your goggles at all times. About silver nitrate, it just if a little drop gets on you, it has ability to stain the skin. That is, the silver reacts with a component of the proteins and kind of stains a little. So watch out for that, and again, wear gloves as necessary. And watch out for the waste. In many of these, some of these at least, maybe 2 or 4, you must process the waste appropriately. So certainly look out for that as you come to the end of each particular test. And have some fun, learn, talk, come up with the correct formulas for these ionic compounds. Not only that, but be able to tell us what reasoning led you to be able to write the ionic compound as you come up with. Have fun. Great times in lab. Bye-bye.